Hello and welcome to all students in this our YouTube channel. Students, we are in the topic of chemical bonding. With the continuation of our previous lectures, in our today's lecture we are going to learn a new concept, that is there are different examples of sp, sp2, sp3 hybridizations, and these examples in detail in our today's lecture we are going to learn here. sp3 hybridization in ethane molecule, that is C2H6 molecule, in detail we are going to learn in this or today's lecture. In ethane molecule, both the carbon atoms assume sp3 hybrid state, means each carbon atom in the ethane molecule which possess sp3 hybridization, and how that we have already seen in our previous lecture. One of the four sp3 hybrid orbitals of carbon atom overlaps axially with similar orbitals of other atoms to form sp3 sigma bond, while the other three hybrid orbitals of each carbon atom are used in forming sp3s sigma bonds with the hydrogen atom. Therefore, in ethane, carbon-carbon bond length between two carbon atoms will be 154 picometer, and each carbon hydrogen bond length is 109 picometer. Now here is the formation of the ethane molecule in the diagrammatically form, and its theory we have shown in this slide. Now let us see how sp2 hybridization in C2H4 is now going to take place. Now students, look at this example. In the formation of ethene molecule, one of the sp2 hybrid orbitals of carbon which overlaps axially with sp2 hybridized orbital of another carbon atom to form carbon-carbon sigma bond, while the other two sp2 hybrid orbitals of each carbon atom are used to making sp2s sigma bond with two hydrogen atoms. Because here in the formation of ethene molecule, the hydrogen atoms which are attached to the first carbon atom are in number 2, and to the second carbon atom are in number 2, while the other two sp2 hybrid orbitals of each carbon atom are used to making sp2s sigma bond with two hydrogen atoms. The unhybridized orbital in which 2px or 2py, we can consider either 2px or 2py of one carbon atom overlaps sidewise with the similar orbital of other carbon atom to form a weak pi bond. All of you already learned sigma bond is the strongest bond than that of the pi bond. When the formation of ethene is now going to be takes place, in between them there is a formation of one sigma bond and one pi bond, and we can say that the pi bond which is formed means after forming the sidewise overlap, the bond which is formed pi bond, which is merely weak than that of the sigma bond, which consists of two equal electron clouds distributed above and below the plane of the carbon and hydrogen atoms. Now look at this figure. You will notice here, while during the formation of C2H4, that is ethene, the hydrogen atoms which are present at the first carbon and the second carbon under the overlapping, when the bond is formed along the axis by the overlapping of two orbitals, there is a formation of sigma bond, and in the A figure and in the B figure you will notice here, when the sidewise overlap of 2px orbitals are going to be takes place out of the axis and sidewise overlap, there is a formation of a weak pi bond will takes place. So combinedly we can say that after the formation of C2H4, when two hydrogen atoms of each carbon approaches together, there is a formation of the C molecule that we have already shown in this slide. There is a formation of C2H4 is going to be takes place. In this case, to the first carbon there are two sigma bonds are formed by approaching hydrogen atoms towards the lobes that we already shown in the figure. The same case is also taking place for the another carbon atom, and in between the two carbon atoms there is a formation of pi and sigma bond is going to be takes place. And if we consider its geometry, all the four hydrogen atoms which are approaches towards that hybridized carbon atom are remained in the same plane. But if we consider here the orbital 2px, which is combined, we can call it as a pi bond formation. They are lies above the one of the means one orbital is having out of the plane, that is above the plane, and another one is below the plane. You will notice here in the figure D the complete formation of C2H4, that is ethene molecule. Thus, in ethene molecule, the carbon-carbon bond consists of one sp2 sigma bond and one pi bond between the p orbitals, which are not used in the hybridization and are perpendicular to the plane of the molecule. The bond length is 134 picometer and the CH bond is sp2 sigma bond with having the bond length 108 picometer. The HCH bond angle is 117.6 degree, while the HCC bond angle is 121 degree. So you can imagine here the bond angle and the bond length, which is shown three-dimensionally in this slide. So this is all about what you can say the formation of ethene molecule. Now students, moving towards the next point, that is sp hybridization. sp hybridization will takes place in the formation of ethyne, or we can also say that acetylene, that is C2H2. In the formation of ethyne molecule, both the carbon atoms undergo sp hybridization having two unhybridized orbital, that is 2py and 2px. As already we have seen here in the previous slide, here in the formation of ethene there are only one unhybridized orbital which is left, that is we have shown in this figure is a 2px. But here we can say that there are two unhybridized orbitals which are present in the formation of ethyne, that is 2py and 2px. Now out of them, one sp hybrid orbital of one carbon atom overlaps axially with sp hybrid orbital of the another carbon atom to form carbon-carbon sigma bond, while the other hybridized orbitals of each carbon atom overlaps axially with the half-filled s orbital of hydrogen atoms, forming sigma bonds. And that formation we are now going to look at in this figure. So students, look at this figure A. You will notice here one of the hybridized orbital of carbon is now going to form a sigma bond with the incoming one of the hydrogen atom, and the similar case which is takes place with the another carbon atom which is now going to form a sigma bond with it. So here is the formation of what you can say the simple carbon with the hydrogen atoms. Now when unhybridized orbitals we are now going to consider here, unhybridized orbitals of first carbon and the second carbon, they form, or we can say they combine laterally. These two axes have shown in this figure B. From this figure you will notice here the orbitals 2px and 2py we have joined with the lines, and by combining these two unpaired electrons from the positive and the negative lobe, here is the formation of single pi bond will takes place, and these pi bonds are weaker than that of the sigma bond, and there is a formation of two pi bonds are now going to be takes place here. And by combining all these things, if we combine the case A and B, you will get the final figure of the formation of ethyne, or you can say the acetylene. In between the two carbon atoms there are three bonds are now you will notice here, that is out of them one is the sigma bond and the remaining two bonds are in the form of pi bonds. So in between carbon and carbon in ethyne, or we can say the acetylene, there are triple bond is present. Out of them, two are pi bonds and one is the sigma bond. And if we consider about the hydrogen atoms which are approaching towards the hybridized carbon atom, there is the formation of one single sigma bond will be takes place for each carbon atom. So in this molecule totally we can say that there is the formation of 3 sigma bonds and 2 pi bonds. So this is the final figure of the formation of ethyne, or you can say the acetylene. This figure C, you will notice here how the formation of acetylene is going to be takes place. But here each of the two unhybridized p orbitals of both the carbon atoms overlap sidewise to form pi bonds that we have shown here, that is 2px and 2py. They combines laterally, or we can say the sidewise overlap. So the triple bond between the two carbon atoms is made up of one sigma bond and 2 pi bonds that we have already seen in this slide, and we have already explained that concept. So this is the formation of acetylene, or you can say the ethyne. These are the type of questions may be asked in your exam. Explain the formation of acetylene on the basis of hybridization concept. Now students, hybridization of elements involving d orbitals. For such examples, we are going to consider one of the table. Here coordination number, hybridized orbitals, molecular geometry and examples we have mentioned in this table. The elements present in the third period contain d orbitals in addition to s and p orbitals. The energy of 3d orbitals are comparable to the energy of 3s and 3p orbitals. The energy of 3d orbitals are also comparable to those of 4s and 4p orbitals, because they are having a very or we can say they resembles each other, or there is a very less energy gap is present in between that 3d and 4s 4p orbitals. As a consequence, the hybridization involving either 3s 3p and 3d or 3d or we can say the 4s or and 4p is possible. However, since the difference in energies of 3p and 4s orbitals is significant, means you can say no hybridization involving 3p and 3d and 4s orbitals is possible. So you will notice here some of the examples in which the molecular geometry we have mentioned and their hybridized orbitals which are present in either sp, sp2 or sp3 or d sp2 sometimes. Those molecules which possesses the square planar geometry, for example tetracyanonickelate, for such examples and tetra amino platinate, or for such examples we can say that as their geometry lies in square planar and having the hybridization dsp2, for such examples their hybridized orbitals we have mentioned here and their corresponding molecular geometry is also explained in this table. Now students, after this we are going to learn the new hybridizations, that is sp3d or dsp2, and in this table we already explained all these concepts, that is types of hybridized orbitals, that we are now going to learn in our next lecture. So this is all about in our today's lecture. We will come with new different examples in our next lecture. Thank you very much.